Hello, I'm Aeri from Seoul National University. I'll present our paper ZADU, a Python library for evaluating the reliability of dimensional reduction embeddings. This is a collaborative work between Seoul National University, KAIST, Samsung Electronics, and Hyung-Kwon University. Dimensionality reduction is a very popular technique for high-dimensional data analysis. At the same time, it has an inevitable risk of distortion. So, to prevent misinterpretation, we should always pay attention to the distortion and verify whether this is trustworthy or not. Therefore, many methods have been proposed to evaluate the reliability of embeddings from various perspectives, such as neighborhood relationship or cluster structure. These metrics can also serve as standards for comparing which dimensional reduction method to use. However, integrating this essential process into your analysis remains a practical challenge. Due to the lack of a unified implementation of metrics, installing and executing these pieces of code can be quite a time-consuming process. This is one of the factors that causes users to easily skip the evaluation process. That's why we introduced ZADU, an easy-to-use and comprehensive Python library for evaluating dimensional reduction embeddings. It covers a total of 17 evaluation metrics at 3 levels of measuring distortion. 7 at the local level, 4 at the cluster level, and 6 at the global level. You can find a list of all supported measures on our paper or GitHub. For more detailed analysis, we also provided aggregate result as well as the contribution of each individual point to the overall distortion for some measures. Using this information, analysts can explain distortion in a fine-grained manner. For example, they can check local distortion according to the class and see which classes are vulnerable to the distortions. And two visualization methods for local distortion, check-fit and reliability map are also included as a use case for ZADU, named ZADU VIS. I'll show you a demo of how you can easily evaluate the dimensional reduction embeddings using ZADU. For the demo, I prepared a Google Colab where I already imported several libraries such as scikit-learn and MNIST dataset, which is a variable named HD. Then I created Disney embeddings, and this is a variable named LD. Before jumping into the real data analysis with this embedding, I want to ensure that this is a reliable embedding or not. This is exact timing using our library ZADU. You can install and import ZADU like any other Python libraries. Then, the next step is to specify what kinds of evaluation measures you want to use. I choose one from each of the 3 evaluation levels: trustworthiness and continuity for the local measure, steadiness and continuity for the local cluster measure. And for the measures that require the parameter, you should also specify that in the spec object. And finally, distance to measure for the global level. If the parameter is not required, just leave it blank. Create a ZADU instance, and as arguments, you should give the spec I declared before and the original data. Using this instance, ZADU automatically optimizes the execution of multiple measures. When you call this instance's measure function, it will compute the result. Returned values are the evaluation result and point-wide distortion if you set return local flag as true. You can see the results corresponding to each metric you specified. Finally, to visualize this point-wide distortion, import ZADU VIS. You can call check-fit or reliability map instance from ZADU VIS. and use embedding and point-one distortion result as their arguments. This is the visualizations ZADU VIS provided. With these visualizations, you can check which part of the embedding has more distortion. This is the end of our demonstration. As an evaluation for ZADU, we conducted a runtime analysis. We analyzed the effect of optimization on execution time when using 5 measures as objective function of UMAP's hyperparameter optimization. As a result, ZADU's optimization resulted in speedup of 1.5 times. We also show the scalability benefit of ZADU as the speed advantage increases even as the dataset size increases. To sum up, ZADU is an easy-to-use and efficient library for evaluation of dimensionality reduction embeddings that significantly reduces researchers' time waste. You can find more information and install ZADU on these links. Thank you.